Hi everyone, welcome to Byte and Beyond with Uday. In this video, we are going to learn about interface segregation principle. So let's begin. First, we will see the example of uh, bad design, and we will by taking example of bad design, we will understand what is interface segregation. All right. So if you see the design over here, this is an interface multifunction device and that includes three methods: print, scan, and fax. By looking at this interface, we see there is nothing wrong in it until the class implements it. So, for example, over here I have concrete class which is SimplePrinter. All right, and if you see, SimplePrinter has ability to print print the paper only. It cannot scan or fax. All right, but because this simple printer implementing this multifunction device, this class has to implement these additional methods as well, which are scan and fax. Why? Because whenever we implement any interface, whatever abstract methods has been declared in that interface, we need to implement in the concrete class. So in our case, simple printer is a concrete class and multifunction is a multifunction device is a interface. And our concrete class has to implement this method and throw an exception, unsupported operation exception. Because simple printer can only print, it cannot scan or fax. So why this problem occur? Because we haven't segregated interface well. Because what is segregation? I mean, we need to add methods inside an interface which makes sense when we see the when we see from the concrete class point of view. Because um, for example, simple printer, there can be another class which is simple scanner, which can only scan. So we should not add all of the methods inside one interface. Instead of that, we should create multiple interfaces. All right. I will talk about good design as well, but I hope by looking at this slide and my explanation, you understand what is the problem if we do not segregate the interface. Do not segregate meaning you add all of the methods inside a single interface. All right, and then that interface is going to be implemented by some classes, and those classes might not have those ability. In our case, simple printer does not have the ability to scan or fax. So now we are in trouble. So how does it looks when we see in the actual classes? So for example, by taking the slide reference, you can see I have created one interface, multifunction device, and you can see three methods, abstract methods: print, scan, and fax. Now we have a simple printer over here, and you can see this printer has ability to print the document, but it cannot scan or it cannot fax. All right, so I need to throw an exception from here that this operation is not supported. Scan and fax not supported. So I'm throwing an exception. Now let me go to the tester class, and I have created one object, and now assume this printer, simple printer, is being used in some other classes. All right, some other web application or any classes. All right, at any application, let's say. Now somebody is calling simple printer print method. So let me run this. Because simple printer can print the paper or print the document, you can see we are getting the proper output, printing document. that is acceptable. Now there is another example. Now that user who is using this simple printer class might think, hey, what are other methods this simple printer have? So I can see there are scan and fax. So let me use scan. So if I run this, you can see I'm getting exception because scanning is not supported. Scanning is not supported by simple printer. You can see message scanning is not supported by simple printer because this functionality is not supported by the simple printer. Now the developer or the user might think, let me use fax. What about fax then? If scanner is not working, what about fax? So it again throws the exception. Faxing is not supported by simple printer. Then the user might think, if this operation are not supported by this simple printer, why the does this operation exist? So that is the question, that is the problem. If this operation are not supported by simple printer, it should not be part of simple printer. Simple. All right. So that is the problem. If we should add methods which are supported by the class. All right, we should not add any methods, not a single method, which are not supported by class. So over here, scan and fax not supported by class, but still it is here. Why? Because we haven't segregated this interface. So this is the example of bad design. I hope you understood this point or this concept now. This is the example of bad design, and this is the problem we ran into if we do not segregate interface. All right. So now what is the solution? So let me show you the solution. All right. So first I will show you the slide, and then we will implement as per the given slide. We will create those interfaces and those classes, so we get better understanding. So this is the good design. Now we are segregating our interface. So if you see, instead of single interface, earlier we had only one interface. All right. Now I want to segregate this interface. So segregate meaning divide those interfaces. I mean divide those methods. All right. So if you see printer, I have created three interfaces: printer, scanner, and fax. And print method goes to printer class, scan method goes to scanner class, and fax method goes to fax interface. Now, now we have three interfaces. So what I will do, I will create simple printer class. Now simple printer only implements the printer interface. All right, because simple printer has ability to print. So it will only implement this printer interface. So now this simple printer does not have to or does not has to does not has to implement other methods such as scan and fax, because now we have segregated our interfaces. Now we have segregated our interface. We have divided all of those methods across the interface. So our simple printer become part of good design, and now it has only one method, which is print, and that is correct. So let me same for the scanner. Now let's say there is another class, scanner, simple scanner. It has ability to scan, so it will only implement this scanner interface. Now there is another concrete class. Let's say simple fax. It has ability to fax, so it will only implement only fax interface. All right. Don't worry about this theory. I am going to create all of these classes and interfaces. So don't worry about this for now. All right. Now let's say we have another device which has all the abilities. So what it will do, this multifunction printer, it has ability to print, scan, and fax. So if this class has ability to do all of the things, it will implement all of these three interfaces. All right. and it will implement those methods. So let me show you how exactly it looks when we convert this slide to classes and interfaces. So let me go to my IDE. All right, let me close this things, close all tabs, and let me create one package over here. Package, and instead of bad, let me say good design. What do you say? Invalid package name format. Okay, invalid package name format. It doesn't want to create. Okay. Let me package. Okay. There was a dot. Okay, that was the problem. Okay, no worries. Let me create one interface as per the slide. Let's say printer. All right, and it has a method which is, let's say, print. It's a divide and print. I'm not going to add anything over here. That is it. All right. Now let me create one concrete class. That's a simple printer. All right. That implements the printer interface. All right. Gen AI is giving me suggestion. That's fine. Let me implement the method which is print. All right. And printing document. So now you can see simple printer has only one method which is print. As per the slide, if I go to the slide, we have interface printer. If you see, this is the interface printer. It has only one method print as per the slide print. And we have a concrete class as usual, simple printer. Now that is implementing this printer interface. And if I create a extra class to run these classes, let's say good tester. All right, let me create public static void main, and let me create okay, you want now scanner. Yeah, so this is good. So you can see simple printer dot print. So if I run this, all right, but if I say printer dot, there is no scan or fax method, right? Because our simple printer is now implementing only the printer interface. So uh, there is no problem. There is no issues, right? There are no issues because there are only relevant method which is print. There aren't there aren't any irrelevant methods such as scan or fax. All right. Now similarly, let me create two more interfaces. All right. One is scanner. Let me add a method which is say scan. All right. And one more interface which is fax. All right. Fax. This is also method fax. All right. So as per the slide, I have created two additional interfaces, scanner and fax. You can see this is fax, this is scanner. It has scan and fax methods. Now let me create, as per the slide, let me create two classes. Let's say simple scanner and simple fax. So those classes will implement the required interface. Let's say simple scanner. All right. This is going to implement scanner interface. You can see scanner interface. Similarly, if I have fax class, okay, let me see the class SimpleFax. Let me create SimpleFax, and this will implement the fax interface. Now it has faxing ability. All right. So if I close everything, so as per the slide, simple scanner, we have simple scanner. It implements the scanner interface, and it has a scanning ability. Same goes for the simple fax. It implements fax interface. Now it has a fax ability. All right. And if we need to use those ability, we can simply go to our class, simple scanner scan. Same for the fax. Simple fax has the fax ability. Now each class has their own ability. Simple printer has print ability, simple scanner has scanning abilities, simple fax has a faxing ability. Right? Now none of the classes has irrelevant methods, such as now fax cannot print. So I don't say any print method over here. So that's how we have solved bed design using our interface segregation principle. Now you are might thinking, what about multifunction printer? Now let me create one more class. That class has all the ability. Let's say multifunction. What a multifunction printer. Yeah, I was just checking a name. Multifunction printer. Now it has all the abilities. So this class is going to implement all of these three interfaces. So you can see printer, scanner, fax. I have implemented three of them. And because this class has three abilities, so it is implementing all these three methods. You can see printer, scanner, fax, because this multifunction printer can print, it can scan, it can fax. So it is implementing three of the interfaces, and it is implementing the method, all of these three methods that belongs to these interfaces. All right. Now if I go to tester class, and if I need to execute this, you can see multifunction printer, print, scan, fax. And if I run this, let's see what will happen. You can see printing, scanning, and faxing. Now again, printing, scanning, and fixing. This is coming from our multifunction printer. Just to separate this out from other print statement, I can add cout over here using multifunction printer. All right. Now if I run this, you will see the clear difference. You can see printing, scanning, and faxing from this two simple printer and simple scanner and simple fax classes, and these three statements are from the multifunction printer. You can see now this can print, scan, and fax. So yeah, that is how, using the interface segregation principle, we can design our software or our application in a better way, and we can convert this bad design to a good design using this interface aggregation principle. I hope this concept is now clear. And if you need this source code, I will put the GitHub link to the YouTube video description. And as always, if you find my video useful, then please like, share, subscribe, comment. See you in the next video. Till then, goodbye.